What is leaching? Answer: it is one of the methods of concentration of ore. It is used if the ore is soluble in some suitable solvent. For example, concentration of oxide, which contains impurities of silica and titanium dioxide, is done by digesting the powdered ore with a concentrated solution of sodium hydroxide at 473 to 523 Kelvin temperature and about 35 to 36 bar pressure. Here, TiO2 remain as such, but Al2O3 and SiO2 are leached out as soluble sodium aluminate and sodium silicate respectively. So we have the reactions: Al2O3 solid plus 2NaOH aqueous plus 3H2O liquid to give 2NaAlOH4 aqueous. This is soluble compound, soluble complex. Into this solution then CO2 gas is passed, where hydrated Al2O3 is precipitated, leaving behind sodium silicate in the solution. So we can write 2NaAlOH4 aqueous plus CO2 gas to give Al2O3 XH2O solid plus 2NaHCO3 aqueous. Finally, after filtration, the dried hydrated alumina is heated to give back pure Al2O3. So we can write Al2O3 XH2O solid heated at about 1470 Kelvin temperature to give Al2O3 solid plus XH2O gas. Question number 2. The values of standard free energy of formation, that is delta G naught F for Cr2O3 is minus 540 kilojoule per mole, and that of Al2O3 is minus 827 kilojoule per mole. Is the reduction of Cr2O3 by aluminium is possible? Let us see the answer. We are given that Cr solid plus 3 by 2 O2 gas, that gives Cr2O3 solid, and delta G naught 1 for this first step is minus 540 kilojoule per mole, and for the second step or the reaction, aluminium solid plus 3 by 2 O2 gas, we get Al2O3 solid. Delta G2 naught is equal to minus 827 kilojoule per mole. But our target equation is Cr2O3 solid plus aluminium solid to give Al2O3 solid plus 2 chromium solid. Obviously, if delta G naught for this reaction is negative, then it will be a spontaneous process. This can be calculated as Cr2O3 solid changing into Cr solid plus 3 by 2 O2 gas. This is the reverse of step number 1 we had earlier written. Therefore, its delta G naught will be shown as delta G1 naught dash, and its value will be plus 540 kilojoule per mole. Then aluminium solid plus 3 by 2 O2 gas gives Al2O3 solid. Delta G2 naught is minus 827 kilojoule per mole. Adding these two reactions, we get Cr2O3 solid plus aluminium solid to give Al2O3 solid plus 2 Cr solid. Delta G3 naught for this reaction becomes 540 minus 827, so that amounts to minus 287 kilojoule per mole. Hence, above reduction is possible. In fact, in this manner, when the reduction of a metal oxide by any other metal or carbon monoxide is possible or not. That can be decided, but it will be a thermodynamic prediction for the temperature at which delta G net is calculated. Other factors like how high temperature will be needed, whether the reaction is kinetically fast or not, must be taken in consideration. Question number 3. How will you get silver from a silver coin? Let us see the answer. Remember, a silver coin contains copper also besides silver. Hence, we take the coin and dissolve that in concentrated nitric acid. That gives us silver nitrate aqueous plus copper nitrate aqueous. Now this solution is heated to remove excess HNO3 and then add hydrochloric acid to it, where a white precipitate of AgCl is obtained. That is taken 4 AgCl plus 2 Na2CO3 fuse to get 4 Ag plus 4 NaCl plus 2 CO2 plus O2, or boil AgCl with NaOH and glucose. So 2 AgCl plus 2 NaOH, we get Ag2O, that is silver oxide, plus 2 NaCl plus water. Then Ag2O plus C6H12O6, they react to give 2 Ag plus C6H12O7, which is known as gluconic acid. The silver thus obtained can be purified further. Well, question number 4. An ornament contains some silver with gold. How will you separate them? The answer is, if that ornament or alloy has gold less than 20%, then it is boiled with concentrated sulfuric acid, where silver is dissolved as silver sulfate and gold remains as spongy mass, which is filtered out. To the filtrate, some zinc dust is added. So, Ag2SO4 aqueous plus zinc, that gives 2 Ag precipitate plus zinc sulfate aqueous. However, if alloy contains gold more than 20%, then some silver is added to it so as to reduce the percentage of gold, to be followed by above method. Question number 5. What is purple of Cassius? Its answer is, it is a form of colloidal gold, and that is prepared as 2 AuCl3, a very dilute solution of auric chloride is taken, plus 3 SnCl2. They react together to give 2 Au plus 3 SnCl4. The gold thus precipitated is adsorbed by SnOH4, which is formed by hydrolysis of SnCl4, that is SnCl4 plus 4H2O to give SnOH4 plus 4HCl.